alaikum wa rahmatullah. Good day, everyone, and I welcome you all to our today's physics class. This class is for 100 level students of the Faculty of Basic Health Sciences and the Faculty of Science and Computing. It is given the code PHY 1202 and the course title is Electricity and Magnetism. Today, inshallah, we are going to explain electric current. Electric current is denoted by capital letter I, as we can see written on the board. Okay, first of all, as an introduction, you need to understand that in the study of electricity, we divide electricity, the study, into two categories. We have the first category that we call static electricity, meaning static electricity, and this is when the charge carriers are not flowing, they are at rest. You have charges at rest, they do not flow, and you are only trying to understand the behavior, the characteristics of those charges at rest. In this situation, you don't have electric current at all, because for you to have electric current, charges must flow. It's just like water. If water is standing still, okay, it's not flowing, we do not speak about water current. Okay, you only speak about water current if the water is flowing. If it is not, no water current. In the same sense, in the field of electricity, we do not speak about electric current if the charges are at rest. If the charges are at rest, we can only try to understand the influence of forces acting on them, such as the Coulomb forces. We can get the electric field, okay, electric field strength at different points, electric potential, and all that stuff, but no electric current because the charges are at rest. So we call the study, that particular study, static electricity. Now, by the time the charges begin to flow from one point in a conductor to other point, they generate electric current. And we no longer call this study static electricity because the word static means stationary, not moving, still in one place. Okay, now that they are moving, we call this study current electricity. So electric current is observed in current electricity only and not in static electricity. Now the next thing is, what does it mean? What does electric current mean? Look at the meaning here. They say electric current is the rate of flow of charges. Okay, so clearly from the meaning we see that the charges here must flow to generate electric current. And how do you define the electric current? Is the rate. You see, you want to know how much coulomb of charges are flowing in a given point in 1 second. This means if I have a conductor, let's say this is a conductor such as a metal wire, and then electric current flows whether in this direction or in this direction. I'm going to assume that it flows in this direction. Electric current flowing through the conductor. Let me take a point here. Let's call this point A, this portion in the conductor. If after 1 second, okay, if after 1 second, the quantity of electric charges that pass through this given point Q is 3 coulomb, then we say that, okay, our current is 3 amperes. Can you see? 3 amperes. And this 3 amperes means 3 coulomb per second, meaning after every 1 second, 3 coulomb of electric charges pass through this point A. This measurement is what we call electric current. You want to know after every 1 second, what is the amount of charges in coulomb passing through a given point. This measurement can be constant. It can also be fluctuating. Okay, The next question, after understanding the meaning of electric current as the rate of flow of charges, what is the SI unit? How do we express the unit? The SI unit of electric current is the ampere. The ampere, and the symbol for the ampere is capital A. A in the upper case, not in the lower case. As you can see, 3A here means 3 amperes, okay, and it means 3 coulomb per second. Okay, the other unit is milliampere, and the M is in the lower case, A in the upper case, milliampere. Okay, why do we have this milliampere? Because we have some devices that 1 ampere is a very large current. When it flows through those devices, okay, it can damage them. Computers, our phones that we use, our chargers, okay, some of them, they have materials in them that 1 ampere of electric current is too much. They cannot withstand it without getting spoiled, getting damaged, okay. So for that, we adopt smaller units that we call milliampere. Of course, we have much smaller ones, but this one is more common in electronics. Okay, you can have microampere as well. You can have picoampere that are much smaller than this, but this milliampere is more common. Okay, how do we write the formula for calculating electric current? You see, the first thing we learned was the meaning of electric current as the rate of flow of charges. The second one is the SI unit, the ampere, but we are adopting the smaller unit because, you know, for some devices we have small current flowing through them. 1 ampere may be very large. Okay, then what is the formula? The current I and charge Q can be related by the equation, meaning you can combine them in a single equation that says I equals dq dt, okay? Meaning when you take the first derivative of Q with respect to T, you are calculating current. This is the differential form. The current can, in this situation, the current can be fluctuating so that after 1 second the current may be different from the current you will obtain after 5 seconds, meaning it is not steady. So I can use this formula to get the current at any given time, provided I know the expression for Q in terms of T. Now, if the current is steady, is constant, I can simply say my I is equal to Q upon T, and from here I can make Q the subject of the formula. I only have to multiply A and T to get the quantity of charge flowing through a conductor. So we can write Q equals IT. You see that? It means that if, for example, I have a conductor, let's say this is a conductor, no matter how long, and then the current passing through this conductor I is 2 amperes. 2 amperes. 2 amperes of current passing through it, and this current passes through this conductor for 30 seconds. For 30 seconds. Now, what is the quantity of charges that flow through this conductor? I have to use this to get it. This is my I and this is my T in seconds. So I multiply these two. The formula equation 2 says to get your Q, multiply I by T. My I is 2 and my T is 30. I multiply this 2 times 30 and this will give me 60 coulomb. 60 coulomb. If they say these 2 amperes flows through the conductor in 1 minute, 1 minute is 60 seconds. You know that you must convert the unit given to you. If it is in minutes, convert it to second. If it is in hours, convert that to second as well before you use the formula. So now this is 60 and then you have 2. So the quantity of charge will now be 2 times 60 and this is gonna be 120 coulomb. That is the significance of this equation. Finally, electric current is a scalar quantity, meaning it has magnitude only but no direction at all. It is not a vector. So if you are asked which of the following is a scalar quantity and you see electric current in the options, take that option, because electric current is a scalar and not a vector. Okay, another thing we should know, you can see from this formula that this is coulomb. Okay, these charges are measured in coulomb, time measured in second. So from this formula, electric current is measured in coulomb per second. This means that one ampere is equivalent to 1 coulomb per second. The two units are the same, but only this one is adapted as the unit of electric current. So when you see 1 ampere, it means 1 coulomb per second. If you see 3 ampere, it means 3 coulomb per second. Okay. You may curiously ask, what is the relationship between ampere and milliampere? I will tell you that this ampere is a much smaller unit, so you have to have 1000 ampere, 1000 milliampere before it will be equal to 1 ampere. 1 ampere. Okay, this must be up to 1000 before you will get 1 ampere. So this means 1 milliampere should be that I will divide both sides by 1000 and I will have 1 over 1000 ampere. You see that? 1 divided by 1000. So 1 ampere is this one. I can rewrite it as 10 to the power of minus 3 ampere. You see? So it means when I am given in milliampere and I am asked to change it to ampere, I will simply multiply by this factor. For example, this 3 ampere, if it is 3 milliampere, for example, to change it to ampere, I will just say 3 times 10 to the power of minus 3, and I have it in in ampere. Okay, this is all that we have today, and I hope you enjoyed the class. Assalamu alaikum wa rahmatullah.